Okay, let's get started with 393. I do want you to draw pretty much all the diagrams in this homework assignment. So go ahead and draw that triangle for 3-93. Pause the video if you need to. And let's look at what we're being asked to do. Ben thinks that the slope ratio for this triangle is 7/10. Carlissa thinks the ratio is 10/7. Who's correct? Explain your thinking fully. Okay, well, actually, both Ben and Clarissa are correct depending upon the angle that you look at. So if I'm looking at 35 degrees, then the slope angle, the change in y over the change in x, would be 7/10. So for 35 degrees, slope, change in y over change in x, is 7/10. So Ben must have been looking at it from the vantage point of 35 degrees. If I trace this triangle, and you should have some tracing paper for this homework assignment, go ahead and trace your triangle. Put the angles on there. Put the length of the two legs on there. If I reflect this and then rotate it, so I'm not being kind of really specific about where I'm reflecting it, but if I reflect it so that, and rotate it so that the 55-degree angle is the slope angle. Okay, let's look at it from this vantage point. Then the change in y becomes 10. The change in x, that was the 7. So for 55 degrees, the change in y over the change in x is, instead of 7/10, 10/7. Which confirms what we saw in our trig table graphic organizer. So I'm going to zoom out on this, but we notice that if you look at complementary angles, if you look at 11 degrees and 79 degrees, so I made you draw some arrows connecting these. So let's see, 22 and 68, you should have some arrows, 11 and 79, 18 and 72. Those are all complementary angles. I think those are the only ones we have. So if I look at the slope for 11, it was 1/5. That was the very first one we started with. And then at the end of the next lesson, we said, what if I'm looking at 79 degrees? And we noticed the same thing, that if you reflect it and rotate it, you wind up with the reciprocal of this slope. So the slopes of, let's write this on this homework assignment. Well, let's look at maybe one or two more. If you look at 18, the slope's 1/3. If I look at 72, slope is 3/1. For 22 degrees, the slope was 2/5. All of these were from the very first resource page. And if I look at the complement of 18 degrees, 22 degrees, 68 degrees, 5/2. Okay, so let's write this for 393. The slopes of complementary angles are reciprocals. And that's the word for what you get when you flip the numerator and the denominator. And that's important because you're relying on you're going to be relying on your calculator for a lot of these answers. And if you are just doing this without having some sense of what it should be, you could easily punch something in the calculator, get a wrong answer, and think it's correct. But if you have a sense of what these should be based on what we've noticed, the patterns we've seen, then you're going to probably catch something that, oh, you may have put that in the calculator incorrectly. You should have some intuitive sense for some of these. Also, the calculator is never going to give you a fraction. It's going to give you a decimal when you're doing these, but that decimal comes from a ratio, from, in this case, a slope ratio. So hopefully this connection is getting stronger and you're seeing what all of these puzzle pieces put together should come out to be. Okay, 394. Use your observations from 392, which is what we did in the lesson with anybody who had this lesson. I know the Morning Blue group did not, but you will get it eventually. Use your observations to answer these questions. Talia did not have a tool to help her determine the slope angle theta in the triangle at right. Okay, so she did not have this on her trig table graphic organizer. However, she claims that the slope angle has to be more than 45 degrees. Do you agree? And why? So let's draw this triangle. If you are looking at the angle theta, the slope for this angle would be, if I'm looking at this angle, change in y would be 6. And slope is my change in y over my change in x, so 6 over 4. And 6 over 4 reduces to 3 over 2, and as a decimal that would be 1.5. So let's look at our trig table graphic organizer. So she says the angle has to be more than 45 degrees. Well, if you look at your trig table graphic organizer, you're noticing, or you should have noticed, that all of the slopes for angles that are less than 45 degrees are less than 1. The slope of 8, 0.141, slope of 11, 0.2, 18, 0.3, 22.4, and then you get to 45 degrees, and that was 1 over 1. So she is saying that the slope angle has to be more than 45 degrees. Well, what do you think? If it's 1.429, it's 55 degrees. And she's saying, okay, based on this pattern, I don't know what the slope is, but I know if it's 1.5, it's going to be somewhere over here in the trig table graphic organizer. If I had room for it, it's probably a little bit bigger than 55 degrees. So that matches what we're seeing. It's not going to be less than 45 degrees if the slope is 1.5. So let's put Talia is correct. Because, whoops, kind of wrote that funny. Talia's correct because angles greater than 45 degrees have slopes greater than 1. Okay, part B. Lyra was trying to determine the slope ratio for the triangle at right. The answer is change in y over change in x is 2.675. Isaiah claims that cannot be correct. Who's right and how do you know? So draw this triangle. Okay, so I want to remind you, you should have that another tab with the eTool open to this problem so that you can kind of look at the problem even when it's not on the screen. So she says that the answer, the slope is 2.675 for a 19-degree angle. Well, let's look at our trig table graphic organizer. If you look at all of the angles that are less than 45 degrees, they're all less than 1. And if you're looking at this one's 19 degrees, we do have 18 degrees. That one was 0.3. So it's probably a little bit bigger than that, but not that much bigger. So Lyra cannot be correct. The slope can't be that big because anything less than 45 degrees is less than 1. So Isaiah must be correct. So let's put the change in y over the change in x. The slope has to be less than 1 because the angle theta is less than 45 degrees. So if it's bigger than 45, it's bigger than 1. If it's less than 45, it's less than 1. Okay, part C, without determining the actual value, what information do you know about x in this diagram? Okay, so let's look at this. Go ahead and draw this triangle. I know that the slope for 76 degrees, I know it's greater than 1. So that means that the change in y over the change in x, in this case 9 over x, has got to be bigger than 1. Well, if this is bigger than 1, think about it. What could you divide 9 by and get an answer that is bigger than 1? If you did 9 divided by 2, that would be 4.5. Okay, if I did 9 divided by 3, that would be 3. So if I'm getting an answer that's greater than 1, then this denominator has to be, think about it, if you did 9 divided by 9, that would equal 1. If you did 9 divided by 10, that's 0.9. So this denominator, it's got to be less than 9. It's got to be smaller than 9, because if it gets bigger than 9, then the slope is going to be less than 1. So that means x has got to be less than 9. X has to be less than 9, even though I don't know what this change in x is. I know the slope is going to be greater than 1 because anything above 45 degrees, it's going to be bigger than 1. So I know that this denominator has to be smaller than 9. Even if this isn't making perfect sense today, just stick with it. It's going to click, and you may not revisit this again for a while, but having these seeds planted, they're going to grow. Okay, let's look at 395. It says, and go ahead and pause the video if you need to, I would like you to draw these triangles because we're going to put some markings on these. So it says, for each pair of triangles below, determine if the triangles are congruent, identical, similar but not congruent, okay, like siblings, or if you just can't figure it out, or if the relationship cannot be determined from the information given. If they are congruent, organize your reasoning into a flowchart. We have not done flowcharts. I am going to do a flowchart for one of these examples. Remember that the triangles may not be drawn to scale. Okay, so let's start with part A. Oopsie. We have an angle that's congruent to an angle. We have another pair of angles that are congruent. So we have two triangles, and we've got two angles in one triangle congruent to two angles in another triangle. That should ring a bell. That means that this third angle, which we can figure out, 120 plus 35 plus x equals 180. So that missing angle must be, let's see, 120 and 35 is 155. So if I subtract 155 from 180, I get x equals 25. So this angle must be 25 degrees. So these look like they're congruent, but remember they're not drawn to scale. The only thing we can conclude here is that these triangles, triangle ABC is similar to triangle DEF by angle. The conditions for similarity are in the math notes for a previous lesson. There are 3 conditions for similarity. Angle is one of them. So one of these is a dilation of the other. Okay, that's all you can say about part A. Part B, we have an angle congruent to an angle. We have a second pair of angles that are congruent, and I forgot to write something on here, I think. This is 2. We have a side congruent to a side. So these 2 triangles, if you remember the conditions for congruence, so for 2 triangles to be congruent, there are several conditions for congruence: SSS, SAS, angle side, and angle side angle, and then the last one is HL. Well, we can rule out HL. We're not dealing with 2 right triangles. We don't have 3 sides congruent to 3 sides. We don't have 2 sides, so we can rule out SAS. So it's got to be 2 angles and a side. And if you look at where the side is not in between the 2 angles. So it's not angle side angle. It's angle side. And this one we are going to do a flow chart. So a flow chart is just basically writing out how you know that these 2 triangles are either congruent or similar. So we're going to start with writing the parts that are congruent. So we have NO is congruent to QR. Okay, and for a flow chart, you just put each statement in a bubble. Now that information was given. You put the reason you know that's true underneath the bubble. So we know that these are congruent. That was given to us. We also know that angle O is congruent to angle Q. That was also given. And we know that angle M is congruent to angle P. So this is the most basic flow chart that you might have to do. We might see this on the semester exam, and I won't see that until probably a week before the exam, so it wouldn't hurt if we review it. And then with a flow chart, you just draw arrows from your information saying basically these arrows lead to the following conclusion. If I know that this pair of sides, this pair of angles, and this pair of angles are congruent, then I can say triangle NOM is congruent to triangle. Let me make sure I match these up right. Let's see, N corresponds to R, so I'm going to put R first. O corresponds to Q, so Q is going to go second. So RQP. And the reason I know that's true is angle side angle forces 2 triangles to be congruent. They have to be congruent. If you have 2 angles congruent to 2 angles and a side that is either in between the angles or not in between the angles, 2 angles and a side is always going to work, unless you have something tricky where this angle, where this side wasn't across from 15, but in this case, this congruent is across from 15 in both triangles. So these 2 triangles are congruent by angle side angle. Okay, part C, we have an angle congruent to an angle. We have a side congruent to a side. And then we have another side congruent to another side. Now this, you might be tempted to say, oh, isn't this side angle side? And it looks like side angle side if you're looking at this triangle, but look over here. Here the 62-degree angle would have to be included between the two sides for it to be side angle side. So that's kind of a tricky one. In this case, not enough information. If you were only looking at this one and doing this one quickly, you would say side angle side. But you do need to be careful and check that that angle is included in between the two sides for them to be congruent. Okay, I know there's a lot of drawing on this one, so pause the video when needed or if I'm going too fast. Moving on to 396. The directions say to multiply each expression below, simplify if possible. So here we have a monomial being multiplied by a binomial. Monomial just means it has one term, and binomial means it has two terms. So let's use an area model. Although this one's easy enough, you could probably just distribute it. So 2x times 3x minus 4. So if you want to distribute it, that's fine. So 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. You would get the same thing if you just did it without the area model. And then these are not like terms. That's it. That's your answer. So this equals 6x squared minus 8x. So this is written as a product. And then this would be written as the sum. Okay, for part B, I'm going to do a 2 by 2 square. And I'm going to put my terms around the perimeter of that square. X times 2x is 2x squared. 3 times 2x is 6x. X times negative 5 is negative 5x. 3 times negative 5 is negative 15. This is the area written as a product. This is the length and the width. And yes, I believe I'm remembering this right. There's one like this on your next test. And then if I write it as a sum, this would be 2. So this equals 2x squared. Now these two terms are alike. I'm going to go ahead and combine these. Positive 6x and negative 5x would give me positive x, positive 1x. When you're combining like terms, you are adding the coefficients. So then my last term would be minus 15. This is the area written as a sum. Okay, part C, we've got the product. And notice you have the same terms. One just has a plus and one has a minus. You might remember this from a previous video. It will come up again, and if you can get a hang of this pattern, it will benefit you as we move forward. So 2x plus 5 and 2x minus 5. 2x times 2x is 4x squared. 5 times 2x is 10x. 2x times negative 5 is negative 10x. And 5 times negative 5 is negative 25. So as a sum, this would be 4x squared. When I go to combine these terms, they cancel each other out, because when I add positive 10 and negative 10, I get 0. So I'm not going to write anything for these two terms, and then minus 25. This is a difference of two squares. And I'm going to go ahead and write something to help you. This is a plus b times a minus b, and it always equals a squared minus b squared. See how 2x squared is 4x squared? and 5 squared is 25, and it will always be a minus because the positive times the negative is always going to give you a negative, and these two terms are always going to cancel each other out. So after we cover this pattern, I will not do the area model. I'll just say, oh, I know that's going to be a squared minus b squared. And you'll be a little ahead of the game if you've got that figured out. Okay, we could distribute. First, we could do these two binomials. It really doesn't matter. Why don't we just go ahead and do x times 2x plus 1. So that would give us 2x squared. X times 1 is x. And then let's do an area model for these two. Okay, so this is my product. 2x squared, x, and minus 3. So that's going to give me 2x cubed, x squared times x. When you're multiplying powers, you add the exponents. This has an exponent of 1. 2 plus 1 is 3. X times x is x squared. 2x squared times negative 3 is negative 6x squared. And then x times negative 3 is negative 3x. So let's see, do we have any like terms here? We've got x squared and negative 6x squared. So as a sum, this is going to be 2x cubed. Remember, when you're combining like terms, you're adding the coefficients. The coefficient of x squared is 1, so I'm adding a positive 1 and a negative 6, which would give me negative 5x squared minus 3x. So there's the answer written as a sum. All right, next we have $397, and it says to plot these points on graph paper. We're going to rotate this quadrilateral clockwise. So let's go ahead and graph these points. We've got A is at 0, 3. So 0, 3 would be 0 on the x-axis and 3 on the y-axis. B is at 2, 5. C is at 6, 3. And then D is at 4, 1. Okay, let's go ahead and connect these vertices. Okay, so again, part A said to rotate it 90 degrees clockwise about the origin to form A prime, B prime, C prime, D prime, and then name the coordinates of B prime. So take your tracing paper. Hopefully you should have enough room on that same sheet of tracing paper. Trace A, B, C, D. And put a little XY axis right on top of your origin and put your pencil on the origin. Now I'm going to rotate 90 degrees clockwise, so that's the same direction as the hands of the clock. So there's 90 degrees right there. So it looks like A is going to be, instead of being at 0, 3, it's going to be at 3, 0. B prime, the new B prime, is going to be, it looks like at 5, negative 2. Mine's not quite on there, but I think that's where it's supposed to be. C is going to be at, instead of being at 6, 3, looks like it should be at 3, I think mine just needs to be moved over a little bit. 3, -6. And then D, instead of being, it's going to move from 4, 1 to 1, -4. So I'm just going to write those on here. Let's see, A would be 3, 0. B would be 5, -2. C prime 3, -6. And then I'll graph them. Let me zoom in a little. Okay, so A is now at 3, 0. Or I should say A prime. Let me see. Let me graph them and then I'll figure out where to put the letters. B is at 5, -2. C is at 3, -6. And then D is at 1, -4. Okay, so here's C prime, D prime, A prime, B prime. So rotating 90 degrees clockwise, flipped our coordinates, and the new y coordinate is now negative. Let's see, D prime was 1, -4. Okay, part B says to translate A prime, B prime, C prime, D prime up 8 units and left 7 units to form A double prime, B double prime, C double prime, D double prime. Name the coordinates of C double prime. Okay, so let's translate that. Up 8, left 7. Okay. So if I move everything up 8 and left 7, okay, that's the new A prime, A double prime, and that would be at, I'm going to show you on the graph and then I'm going to do it without the graph. Let's see, 1, 2, 3, 4, -4 and positive 1, 2, 3, 4, 5, 6, 7, 8. So -4, positive 8. Now, all of those points moved up 8. Look at the coordinates of prime, which, let's see, did I write those down? I did not. That was 3, 0. If I move that up 8, the y coordinate went from 0 to 8. The x coordinate went from 3 to -4. Isn't 0 plus 8, 8? And isn't 3 minus 7, -4? Okay, let's look at B. If I move B up 8, 1, 2, 3, 4, 5, 6, 7, 8, left 7, 1, 2, 3, 4, 5, 6, 7. The new coordinates are -2 and positive 6. -2, positive 6. That's B double prime. Let's look at the coordinates. -2 is now positive 6. Well, what's -2 plus 8? Isn't it positive 6? And then 5 changed from 5 to -2. Isn't 5 minus 7 -2? Hopefully, if you've done Khan translating shapes, this is making a connection. It is on your next test. You definitely want to do that Khan assignment. It is not too bad. And once you get the hang of this, you don't have to use the graph. You can just do it without the graph. Okay, C prime, I'm going to go up 8. So up 8 from -6 would be at positive 2. And then I'm going to go left 7. 7 left from positive 3 would be -4. So that's going to be at -4, positive 2. That's C double prime. And if you look at these coordinates, -6 plus 8 is +2, and 3 minus 7 is -4. So moving 7 left and up 8 is the same as subtracting 7 from the x coordinate and adding 8 to the y coordinate. That's the connection that you should be making. Okay, I'm going to do the last point, D. If I go up 8 from -4, that's going to put me at +4. And if I go left 7 from +1, that's going to put me at -6. 2, 3, 4, 5, 6. So D double prime would be at, let's see, -6 and +4. If I look at the coordinates, if I add 8 to -4, I get 4. If I subtract 7 from 1, I get -6. Okay, if that was just too much, you will only have to do one, I think it's 1 point at a time when you do the con assignment. So this is kind of a lot, doing all 4 points. But don't give up. You may not be there yet, but eventually you're going to get there. Okay, part C. After rotating A, B, C, D 180 degrees to form a triple prime, B triple prime, C triple prime, D triple prime, Ara noticed that its position and orientation was the same as A, B, C, D. What was the point of rotation and how did you locate it? So he rotated it 180 degrees to get another transformation, and he noticed that it was oriented the same way as the original. So let's see. Let's take our tracing paper. We're trying to figure out what that center of rotation was. So he did it, and he noticed it was the same orientation. So that means, and he flipped it 180 degrees. So if I rotate it about the origin 180 degrees, that is going to look like this, which is not the same orientation. That would be a reflection. So it must not be about the origin. Let's see, we could try all of these points, but if it's oriented the same way as this original one, let's see, if we did D, let's try a few of these vertices. If I do a rotation around D 180 degrees, that would be 90, that would be 180. It's actually the same orientation, but I think they mean right on top of itself. So I think if we rotate it about any of these vertices, it's not going to be right on top of itself. So it's got to be a point that's actually not a vertex. So I'm going to try this point right here. I think if we rotate it about this point, which is 3, 3, 180 degrees, that would be 90 degrees, that would be 180. It goes right on top of itself. So Ara's center of rotation must have been the point 3, 3. So let's just write Ara used 3, 3 for center of rotation. Okay, this video is getting a little long. We'll wrap this up in a few minutes. So the last one says to enlarge the shape at the right on the graph paper using a scale factor of 2. Calculate the perimeter and area of both shapes. What do you notice when you compare the perimeters and the areas? So let's just quickly, it doesn't have this on a coordinate plane, so let's just do a trapezoid whose bases are 6 and 3. So I'm just using the graph paper to, let's see, 1, 2, 3, 4, 5, 6. The height is 4. Here this base is 3. And this length is 5. So it said to enlarge it using a scale factor 2. So let's see if I enlarge it. It doesn't say where the center of dilation is. So I'm just going to use this point as the center of dilation. So if I do a scale factor 2, this would change from 3 to, I feel like I should use a different color. 3 to 6. 4, 5, 6. This would change from 4 to 8. This would change from 6 to 12. And then this, I'm going to use my straight edge. Let me make sure I got this right. 7, 8, 9, 10, 11, 12. So then this length doubles also. Okay, so my new length here is 6. This new length is 8, 12, and then this would double to 10. And it says to compare the perimeters and the areas. So we're just going to make a little chart over here. The original and the dilation. The perimeter and the original perimeter is 4 plus 3 plus 6 plus 5, which would be 18. So then the dilation has a perimeter of 36 because everything just doubled. The area has, let's see, for the area of my original, this is a trapezoid. The area of a trapezoid is base 1 plus base 2 times the height divided by 2. So then that's going to be, my bases are my parallel sides, 3 plus 6. So 3 plus 6, my height is 4 times 4 divided by 2. So that would be 9 times 4, which is 36, divided by 2 would be 18. Now I'm going to do the area of my dilated image. So let's see, that would be 6 plus 12. My height is now 8 times 8. Divided by 2, so 18 times 8 divided by 2 would be 72. So the perimeter doubled. 18 times 2, let's write this down. The perimeter doubled. The area, 18 times 4 is 72. So the area, let's look at that ratio. 72 over 18 quadrupled. So that's important to notice. The perimeter, it was affected the same way the length of each side was affected, but the area was actually affected by 4, which is the square of 2. Okay, we'll stop there for